So in today's class, we'd like to cover first about the Python sets. Now we have already done list. We know how a list can be declared. In Python, a list can be declared simply by specing the element in a square bracket. And if you try to print type of any variable, it's going to print the type that the specific variable has. So A is of type list. Now data processing has got one of the prolific field, which is set theory. A lot of operations on the real-time data are performed on set theory. We know there are specific set theoretical operation. In order to support that, Python has something called set. Just like a list, you can declare a set. Let's say S is equal to, as normally we declare any set with curly braces, here also you can declare a set with curly braces. So if we print type of S, it's going to return set. Now what is the basic difference between, say, a list and a set? A list is sorted elements, okay, is a ordered list. A list is always having the elements which can be ordered. New element can be added, old element can be removed. But a set is an unordered list of unique values. Let me repeat, a set is essentially an unordered list of unique values. To understand that, let us reverse the order of them. Let's say 11, 12, 3 and 4, and let's say 4, 3. On the other hand, let's give 11, 12, 3, 4, 4, 4. Let's see what happens when we try to execute this. If we try to print S, the value it shows is 11, 3, 4 and 12. You can see that there are actually 3 4s. However, the set doesn't take repeated values. But if you try to print a list can have any number of values repeating any number of times. So one of the things with set is that a set will have unique values of any data type, of course, just like list. So you can have 12, which is a string. You can also have a 4, which is a string, and you can have 4.0, which is a float. So if you execute this, four, 11, 3, 4.0, 12. Why? Even though these are all 4s, this is integer 4, this is a character 4, this is float or double 4. So therefore it has retained all the values. Now if I remove this 4.0, it will only have the integer and the character float. Okay, the last 4 has been removed. So a set is essentially an unordered list of unique values. Now what we mean by unordered list? See, A is declared as 11, 12, 3, 4, 4. If I say A dot sort, then what happens is A is sorted 3, 4, 4, 11, 12 automatically. We know that A will be sorted, a list will be sorted, and the value will be retained by the list itself. What happens if we try to sort? Let's remove this element 12 from here, and let's remove this character from here, just to see if the sorting works or not. So if we say S is equal to S dot sort, you can see it gives a error saying that instance of set has no sort member. Why? Because the set is an unordered list of unique values. So something which is unordered cannot be ordered. It doesn't remember the order. Now this is a basic difference between a set and a list. Now what is the similarity? As far as the set and list is concerned, both can be indexed in the same way. Sorry. Yeah, sorry. Now, because the set object is not ordered, it is not subscriptable, which means that you cannot, access this element in this way. So, just a second. No, because a set doesn't support indexing or slicing, because it's an unordered list. If you wish to print or work with particular elements, all you can do is inline convert a set into list and perform the operation. Okay, now under that situation, so convert S to a particular list, and then you can access the element just like a list. As a whole, the set doesn't support accessing the element in the order. So the set value was 11, 12, 3, 4, 4. The set was 11, 12, 3 and 4, 0 to 2, 0, 1, 2, 11, 12 and 3. That is 0 to 3 we need to give, otherwise it's going to print 2 characters. Yeah, 11, 3, 4. Here also 0 to 3 if we do, it's going to perform the same thing. So this is basically what is a set. Now let us go back and try to perform some set theoretical operation on a set. Now let's declare a set. We know that one of the fundamentals of set theory is a null set. So you can declare a null set simply by writing this is one way where you can print a null set. Else you can also declare a set which doesn't have anything. You can have as many number of elements, let's say 1, 2, 3. Okay, and let's say we have a set called B whose value is 1, 2, 3. Let's say 2, 3, 4. One of the common operation between the sets is a union operation. If we perform union, the common values will be, all the values will be taken out. So the result is going to be 1, 2, 3 and 4. All the values, because 2 and 3 is repeated, it's not going to be taken. So how can we perform union? C is equal to A dot union of B. Let's print C. So C is 1, 2, 3, 4. If we say D, if we try to perform the intersection, 2 and 3 is common in both of them. So the resulting value is going to be 2 and 3. So let's see, B is equal to A dot intersection of B. let's print D. Let's print D with so intersection of A and B is 2 and 3. We know that the third important set theoretic function is difference. We say A minus B, which is a vector operation. Now when we do A minus B, basically all the elements of A which are not in B is going to be printed. So here 2 and 3 is also being present in B. So A minus B should result in 1, right? Let's see. E is equal to A dot difference B, and let's print A minus B is equal to, let's say A minus B is equal to variable E. So A minus B is equal to 1 because A has 1, 2, 3. Out of them 2 and 3 is present in B. So 2 and 3 will be subtracted. See, A minus B means whatever element is present in A which is also present in B will be removed from A. Okay, so A's set will not have the values of the B. On the other hand, if you write A is equal to B dot difference that of A, now observe B has 2, 3, 4. Out of them 2 and 3 is already part of A, so it should print 4. Okay, because B, only 4 is the element of B which is not present in A. So let's see, and this is B minus A. Okay, a thing to be noted is that union and intersections are scalar operation, which means irrespective of whether you write B intersection A or A intersection B, the result is going to be same, but the difference between the two sets is a vector operation. So B minus A is going to be different from A minus B. You can cross check this. See, union of A and B is 1, 2, 3, 4. Instead of writing A intersection, instead of writing A union B, if you had written B union A, the result would have been still same. It would have been 1, 2, 3, 4 itself. It's going to be 1, 2, 3, 4. So union and intersections are scalar operation, whereas the difference is the vector operation. Now Python being a flexible programming language, you can also write A minus B in this way. It is going to perform the same thing, that of difference. Let's see. You see, A minus B is 1. So A minus B you can write directly with the subtract operation. Also you can use the difference function present in the set class by Python to find out the difference between the two sets. Now, because there is nothing called addition operation on this set, if you try to perform something like this, let's see what happens. Let's see what happens. See, it gives an error, unspecified operand of type plus in the set, because there is no set theoretical operation called A plus B, but we have a set theoretical option of A minus B. That is what. So A minus B is supported, whereas A plus B is not supported. Okay. Now you can create the way we saw a bit earlier, that you can convert a set into a list in order to iterate the element. The same way you can create a set from a list. Now let's see how we can create a set from a list. Let's say L is equal to 1 2 3 4 1 2 3 comma 3 comma 3 comma 3. Let's declare it as a list. Now you can see that list has got multiple elements. Now when you say A is equal to set of L, A value list L is equal to 0, set A equal to, let's say 1 comma L comma A. So if we execute list, so L is still 1 2 3 all the 3's, and set A is 1 2 3, rest of the result remains same. So this is how we can perform set operation. Now how to add an element in set. Okay, there are two ways how we can add an element into a set. Let's say, yeah, I created a set by name A from an existing list L. So even if that list has multiple values, while creating this set, it's going to automatically leave out the duplicate values, and it is going to create a set of unique values, right? So here in all the other cases we are creating a set directly. Here we can create a set by calling the set constructor, by calling the set function, and that set function also takes a list as argument. Okay, now yeah, so let's say A dot add, let's say 5, and let's print A after adding. So A becomes 1 2 3 and 5. You can add an element just by calling the add method. Now what if I try to append 6? See, it's going to give a message, set has no append method. Why it doesn't have an append method? Because you cannot index, so it doesn't remember how many elements is there, where exactly the element is, so it doesn't support append element. But you can add elements to set. Now what if I want to add multiple elements to this set? So obviously if you try to add multiple elements, you have to specify them as a set itself. Okay, but Python set doesn't support adding multiple elements through set method. It gives a error that unhashable type set. So using the add method, you can add only one element in a set. However, if we see a list L dot or extend, we can write extend, and we can also give another list. So L becomes 1 2 3 7 8 9, everything. Set A becomes 1 2 3 7 8 9, union of A, intersection of A. So in L we can in a list we can add multiple values, we can append it, but in a set at a time only one value can be added. However, Many practical applications require you to add multiple values together because it makes no sense for a large data set to keep on adding single element or the other. Therefore, Python provides you a special method called update. Okay, now let's keep it simple again. Let's remove this such that we have small enough set and list to know what is there. Now my set value is 1, 2, 3, 5. Now you can write a dot update. In the in the update method, you can pass a set. Let's say 1, 2, 3, 4, 5, 6, 7, 8. Now, thing to be noted over here is when you call the update, it adds the extra values into a set. If you are trying to update anything which is already there, it's going to give a it's not going to give a message, it is going to discard those elements. So set already has 1, 2, 3. I am again trying to update it with 1, 2, 3. 1, 2, 3 is already there in this set. So this whole set will become 1, 2, 3, 4, 5, 6, 7, 8. 1 will not be repeated. So update function will leave out the existing value. As you can see, a becomes 1, 2, 3, 4, 5, 6, 7, 8, just like this. Okay, so whatever value you have tried to add, it's going to add. You can also add, let's say 6. 1, 2, 3, 4, 5, 6. The thing is, if you have a particular value in a set and if you try to update it, irrespective of the number of times you add it, you do not get any error. However, there will be only a single value, that is only one time it is added. But that's not the true. That's not true for the case of add function. If you try to add the same value again, it's going to shoot up a function. Shoot up an error saying that this value is already present in the set. Where is it? Okay, it doesn't give error. So add can be used to add only a single element. Update can be used to update multiple elements. Under both the situations, if you try to put what you call the duplicate element, the duplicate elements are going to be discarded. Okay. Now let's again keep it little simple. Let's a is equal to 1, 2, 3, and let's a is equal to set a. Let's remove this functions. Now the other thing that is associated with any combination is just like adding. You might require to remove an element. Now recall that list has 3 elements. You used remove for removing a particular object. You use del for deleting a particular element, and you also used pop. Pop will return the value that it is deleting. Now let's see how the same thing that appears with a set. Now a dot remove, let's see, 3. Okay, so if I say a dot remove 3, the set a will now become 1 and 2 because I have removed the element 3 from the end, right? Now what if you say a dot remove 3? Now in case an element is not present and you are trying to remove that, it's going to shoot up an error saying that this element is not present, 3 is not there in the list. However, the sets also has a method by name discard. So a dot discard, let's say 2, okay, and let's repeat it. Now you'll see that the remove function, whenever is being passed with a value which is not there in this set, returns an error. But discard function, if you pass an element which is not there in this set, it doesn't shoot an error. So for the first instance, it is going to remove And next two instances, because 2 is not at all present, it is not going to give any error. So these are the two ways how we can, these are the two ways of removing an element from a set. Now, because a set is not indexable, it cannot be used with indexes, or it cannot be sliced. You cannot use del, because you simply cannot use a of 0 because it is not indexable. So again, if you want to use del for deleting an element, convert it into a list first, and then you can delete. So z becomes 1. You are deleting the 0th element. Okay, 0th element is going to be what do you call? Yeah, sorry. Now there is one more case. See, if you are using the delete element, what you need to do is basically you have to take a temporary set, because delete doesn't return anything. Okay, you have to perform the operation, let's say b1, because we are already using b, del of b1, and after this you can write a is equal to set of b1. So in case if you want to use delete command, delete is usable only for list. So you need to convert your set into list, perform the operation, and then convert that list back to the set. So A is an empty set because 0th element you have already removed. So 1 you have removed, 2 you have removed from here, 3 you have removed from here. A becomes an empty set. When A becomes an empty set, the length of an empty set is going to be always 0. Let's see. Length of A is equal to so length of A is 0. Now if A has a value, the length is going to be as many number of element it has got. So a null set has got 0 number of elements. Okay. Now the other method that is applicable for the set is the pop method. Okay, so you can actually a dot pop, let's say p is equal to a dot pop print a is equal to 0 comma deleted element is equal to dot format a comma p. Let's see. So it's going to show A is a null set now. A is a null set. Deleted element was 1 because we had already removed 3, we had already removed 2, 2 was remaining. Just like list, whenever you try to pop a set where there is no element to be popped, let's see what happens. Let's repeat this element. Let's repeat this step. So if you try to pop an element which is not present in the set, it's going to give a message that there is no element to be popped because you cannot pop anything from the null set. So it is always a good idea to use discard function for deleting the set. Or if you at all want to use pop, always keep it in a try and except method. So that's always advisable. Now so we know how to add element in list, how to add element in a set. We know what are the basic difference between a list and a set. We also know how to remove an element from a list and how to remove an element from a set. We now know how we can convert a list to a set or a set to a list. Now we know that there is a Boolean operation available for a set. Let's just remove all of these operations. Let's remove all of this operation and let's try to see some more basic difference. So print 6 in L. 6 is not present in L, so it's going to give a message that false, okay, because 6 is not present in L. If we give 3 or something which is present in 1, it is going to give true. If you have multiple instances of that value also, it's going to return 2. So using in keyword, we can find whether any element is present in a list or not. The same thing is also true for a set. Let's say print 2 in B. So if you say print 2 in B, it's going to return true. Again, this is the statement. It is going to return true because 2 is already there in B. If you say 12 in B, okay, that is false. So both of them supports printing the element which is present. Now we have one more function in list, L dot index of 2. If we say index of 2, it's going to return 1 because 0 and 1, 1th position the index is there, right? So let's say and let's put it in an str because we have used a string. So index of 2 is 1 in L. Now indexing cannot be used in the case of set. Why? Because sets are neither indexable nor sliceable. Let's see if it is possible or not. So where is it? No, it returns. Okay. The index of so the set also supports the indexing the index function. Even though it cannot return the index, we cannot access the set with the index value, but the index function returns the first occurrence of, the occurrence of the or the position of the value. Let's say index of 3, if we say sorry, no, it is L. I need to give B. That's what I got a little confused. You see, set object has no attribute called index here, and that's what I got. So set has got no attribute called index. That's because sets cannot be indexed, they cannot be sliced, and also we have already learned that the set cannot be sorted because it's an unordered list. So this is how we can use set. Any set theoretic operation we can perform with the help of sets. Okay, so the most common methods are update, add, remove, discard, union, intersection. There is one last function that I want to discuss. Let's say L is 1, 2, 3 and A is set of L, B is 2, 3, 4. Now there is something called symmetric difference. Okay, let's print F. And let's see what this symmetric difference is all about. If you run a symmetric difference of B and A is 1, 4. if you write symmetric difference of A and B, that's also the same thing. Okay, so what exactly is a symmetric difference? Symmetric difference is the union of A minus B union B minus A. That's the symmetric difference. So a symmetric difference can be given by S is equal to A minus B union B minus A. So this is what is a symmetric difference. So this is how literally we can work with the set theory.